Now let us see some examples based on the basic definitions of uh, modulus, amplitude, as well as the algebra of complex numbers. Now here is first sum, in which we have to evaluate the addition of these two complex quantities. Now in the beginning, as we know, we have to first merge the two fractions. So therefore on cross multiplying, we will get 1 minus 2i into 3 plus 2i plus 4 minus I into 2 plus I whole divided by 2 plus I into 3 plus 2i. So that equals. Now when we want to multiply the two complex numbers, we know that first we calculate the real part of the final product by multiplying both the real parts as well as both the imaginary parts. So real into real, 1 into 3 will give us 3, and minus 2i into plus 2i, which gives us minus 4i square, which in turn is plus 4 because I square is minus 1. So here we have plus 4. Now to get the imaginary part, we have to multiply one real and another imaginary. So therefore we have 1 into 2i, which gives us 2i, and minus 2i into 3, which gives us minus 6i. So this is the answer of first multiplication in the numerator. Now if we consider the second multiplication, similarly we can write down the real part as 8 plus 1, and the imaginary part will be calculated as minus 2i plus 4i. Now similarly we will continue in the denominator. The real part is 2 into 3, which is 6, plus I into 2i, which is minus 2, and the imaginary part is I into 3, which is 3i, and 2 into 2i, which is 4i. So we collect all the real parts in the numerator and all the imaginary parts. So therefore here we have 3 plus 4, which is 7, and 7 plus 9, which is 16. Then 2i gets cancelled, see, and we have minus 6 plus 4, which is minus 2, whole divided by 6 minus 2 is 4, and 3 plus 4 is 7. Now we know that we have to make the denominator as completely real, so that we can separate the real and imaginary parts of the final answer. So for that we multiply and divide by the conjugate of the denominator, which is nothing but 4 minus 7i. So now on simplifying, we will get the final answer as 10 upon 13 minus 24 upon 13i. So this is how we have got the final answer in the separated real and imaginary parts, which is often essential while working on complex numbers. Now let us see the next question. Find the smallest value of natural number n such that 1 plus I upon 1 minus I whole raised to n is real. Now here first of all let us simplify the expression which is inside the bracket. So 1 plus I upon 1 minus I is equal to, as we know, we have to do the multiplication by conjugate of the denominator, which is nothing but 1 plus I itself, because we have to make the denominator as completely real. Now in the numerator you have 1 plus I the whole square, so which gives us 1 plus 2i, and I square is minus 1, and in the denominator we have 1 minus I square, which is minus 1. So in the numerator ultimately we have 2i, and in the denominator we get 2, so cancelling 2 we are left with I. So therefore given expression is nothing but I raised to n. Now if we want I raised to n as the real number, so the smallest value of natural number n should be nothing but n equal to 4, because we know that I raised to 4 is nothing but 1. So therefore 4 is the answer. Now let's see the next question. Find the modulus and argument of 4 plus 3i. Now here we know that the mod of a complex number is given by square root of sum of squares of real part and imaginary part. So here if we compare, real part A is 4 and the imaginary part B is 3. So therefore here we have square root of 4 square plus 3 square. And as we know, the numbers 3, 4 and 5 form a Pythagorean triplet. So therefore the answer of this would be equal to 5. So therefore the modulus of given number is 5. And we also know the definition of argument is nothing but tan inverse of b by a. So the argument theta is nothing but tan inverse of 3 by 4. Now this angle is definitely in first quadrant because both real and imaginary parts are positive. So whichever is that angle, it is the argument of the given complex number. Now let's see another question which is based on the concept of argument. Now here we have to check whether the arguments of the two numbers 1 plus I and -1 minus I are same. Now let's consider the first number, that is 1 plus I. Now here the argument theta is given by tan inverse of 1 upon 1. Now here we know that the angle related with tan inverse of 1 upon 1 is nothing but pi by 4, which is nothing but 45 degrees. And the number 1 plus I lies in the first quadrant. So we correctly got the angle which is lying in the first quadrant. Now if we consider the second number -1 minus I, as per the definition of argument, it is tan inverse of -1 upon -1. But here it is not correct to say that -1 upon -1 is 1, and thereby we may land up in the wrong answer of tan inverse of 1, which we know it is pi by 4 or the 45 degrees. But this is clearly wrong because we know that the number -1 comma -1 lies in the third quadrant. So this is the number -1 comma -1, which is -1 minus I. Now if we see the argument of this particular number, we know that it has to be an angle in the third quadrant. So therefore pi by 4 is not the right answer of this particular angle, but we see that the angle is 3 pi by 4 because it is in the third quadrant. So therefore the answer to this particular argument of this second number is 3 pi by 4. So therefore, although the definition is tan inverse of b by a, we have to make sure that we consider the quadrant correctly.